Welcome to Study Loop.
Hello. So here in part A, we consider the following limit, where we have the limit as x approaches a of f of x to the g of x. Well, this is going to be equal to, this is of the form here, 0 to the 0, which we know is an indeterminate form. So therefore, the given limit here, the limit as x approaches a of f of x to the g of x, is an indeterminate form. So yes, this is an indeterminate form. For part B, we consider the limit as the limit as x approaches a of f of x to the p of x. We have f of x to the p of x. So let's go ahead and let y equal f of x to the p of x, and then apply the logarithm to both sides. So therefore, we'd have the natural log of y is going to be equal to, well, the natural log of f of x to the p of x is equal to p of x times the natural log of f of x, right? Log to a power. Power comes out front as a coefficient. So we have p of x times the natural log of f of x. Okay, and then we can then apply the exponential on both sides. So e to the natural log of y is just equal to y. So we get y is equal to, well, e to the p of x times the natural log of f of x. And then we get, well, f of x to the p of x is equal to e to the p of x times the natural log of f of x. So again, applying the log on both sides gives us, we take the limit as x approaches a of f of x to the p of x. That is equal to the limit as x approaches a of e to the p of x times the natural log of f of x, which is of the form here, e to the infinity minus infinity, which in the limit, this is going to be equal to e to the negative infinity, which is going to be equal to 0. So therefore, this given limit is not an indeterminate form. And we evaluate it here and we get 0. For part C, we consider the limit as x approaches a of h of x to the p of x. So then we have, well, the limit as x approaches a of h of x to the p of x. This is going to be equal to 1 to the infinity, which is an indeterminate form. So yes, this would be an indeterminate form. For part D, we consider the limit as x approaches a of p of x to the f of x. So now we have the limit as x approaches a of p of x to the f of x. So here, again, we get the form infinity to the 0, which is an indeterminate form. This is going to be the form infinity to the 0. And yes, infinity to the 0 is an indeterminate form. So yes. And for part E, we have the limit as x approaches a of p of x to the q of x. So for part E, we have the limit as x approaches a of p of x to the q of x. And this is just going to be equal to infinity. So therefore, this is not an indeterminate form. And lastly, we have the qth root of p of x. We take the limit, part F, the limit as x approaches a of the q of x root of p of x. Okay, so this is going to be equal to the limit as x approaches a of what? Well, of to the q of x, right? This is the same thing as saying p of x to the 1 over q of x power, which we get as a form infinity to the 0. So this is going to be equal to infinity to the 0 power, which is an indeterminate form. So yes, this is an indeterminate form.